Hey y'all, today is February 3rd and we are working on a lesson review for lesson 5-4. Now remember all of the notes that we took in class yesterday, the little reference sheet that I gave you on that half sheet of paper, and the notes from this video you can use on your Savvas lesson quiz that you're going to take in just a few minutes. Okay, now let's go ahead and get started. So number one, solve the inequality x minus 13 is greater than or equal to negative 20. Well, the first thing I'm going to do to solve this inequality is I'm going to draw a line through my inequality sign. That helps me see that I have two sides, and remember, whatever I do on one side, I must do on the other. Okay? So now I'm trying to get that x by itself, and notice it's connected to a negative 13. So how do I undo negative 13? Well, I add 13. So I'm adding 13 on both sides. So now on the side with the x, my 13s cancel out and I can bring my x down. So x, and I keep my same inequality sign, is greater than or equal to. Now on the other side, I have negative 20 plus 13, and negative 20 plus 13, whether you do that in your head or you use a calculator, you're gonna get negative 7. X is greater than or equal to negative 7. That right there is our solution. And we're asked to graph that solution on a number line. Now we know we want negative 7 to be kind of sort of in the middle of that number line. So I'm going to start maybe at negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, and negative 4. So I've got negative 7 there kind of sort of in the middle. And what kind of circle do I need at negative 7? Well, because my inequality symbol has a line under it, I need a closed circle. Okay, so at negative 7, I need a closed circle. So I'm going to put in my circle and then I'm going to fill it in to make it a closed circle. Now also remember, because my variable is on the left-hand side, I can use my inequality symbol as an arrow pointing the direction I need to shade. So this is pointing to the right, so I know I need to shade to the right. So I'm going to shade all of these numbers here and the arrow because it keeps on going. And that makes sense, right? Because our inequality solution was x was greater than or equal to negative 7. So I did shade all of the numbers that were bigger than negative 7. Okay, let's look at number 2. Solve the inequality. 9 divided by 2 is greater than or equal to b plus 5 over 4. Okay, so we follow the same steps whether we have integers or rational numbers, in this case fractions. So our goal is still to get that b by itself, and the good news is we don't have to graph. We're just going to solve this inequality. So I'm going to draw a line through my inequality sign, and I'm trying to get this b right here by itself. Now it's connected to a positive 5 over 4. So how do I undo a positive 5 over 4? Well, I subtract 5 over 4. And I do that on both sides to keep everything balanced, right? So on the side with the b, my 5 over 4 cancels out, and I have b by itself. My inequality sign stays the same, greater than or equal to. Now on the other side, I've got two fractions, right? 9 divided by 2 minus 5 divided by 4. I could put that in my calculator, but I can very easily do this in my head. The problem is I don't have the same denominator. Can I easily transform one or both of these fractions to get the same denominator? Yeah, I could. What denominator would I use? I would use 4. And I know that 2 times 2 is 4, so I'm going to multiply this fraction by 2 on the top and bottom. So 9 divided by 2 is actually going to become, and I'm going to change my color, 18 over 4. And I'm going to leave my second fraction the same, so minus 5 over 4. Okay, now that I have the same denominator, I can focus on my numerators. 18 minus 5 is 13. So 13 over 4 is my answer. So 13 over 4 is greater than or equal to b. Now, could I also write that to where I have a mixed number? Yeah, how many times does 4 go into 13? 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Okay, so I know it goes in 3 times, and there's 1 left over, so 3 1/4 is greater than or equal to B. That would also be a very acceptable solution because these are equivalent answers. They are the same answer. They mean the same thing. I could always change it to a decimal. 3.25 would also work. Now I want to ask you this question. What if I wrote it so my B was over here on the left-hand side and 3 1/4 was on the right-hand side? What would happen to my inequality symbol? Would it stay the same or would it change? Well, notice the open side is next to my mixed number. So wouldn't I need to keep the open side next to my mixed number and the pointy side next to my B? Yeah, I would. So my inequality sign would actually flip. So it would become B is less than or equal to 3 1/4. So again, this is another equivalent acceptable answer. Okay? Moving on to number 3. And number 3 seems confusing, but on this one in your Sabbath lesson quiz, you're just going to click on drop-down boxes where the blanks are, and you're going to fill in with the correct answer from the drop-downs. So it's kind of multiple choice. Okay? I am giving you a little FYI. 1 pound is equal to 16 ounces. So keeping that in mind, Lacey is shipping a package to her friend. The maximum weight of a medium flat rate box is 24 pounds, including the box which weighs 10 ounces. Sorry, the box doesn't weigh 10 pounds, it weighs 10 ounces. Write and solve an inequality to describe the possible weight in pounds W of the contents that Lacey will ship to her friend if she must use a medium flat rate box. Explain. Okay, so the weight of the box and the weight of the contents of the box must be something compared to 24 pounds. And if we read our problem very carefully, we know that the maximum weight of the box and contents is 24 pounds. It cannot exceed that. So maximum is our key word. Look at your reference sheet that I gave you yesterday. What inequality symbol goes with maximum? If you said less than or equal to, you're correct. Because every time you see that word maximum, I want you to think of the inequality symbol less than or equal to. Okay? So keeping that in mind, the weight of the box and the weight of the contents of the box, the goodies that are inside the box, must be what compared to 24 pounds? Well, they must be less than or equal to 24 pounds, right? Because they can weigh exactly 24 pounds. It can weigh 23 pounds, but it cannot weigh 28 pounds, right? So less than or equal to is what goes in that blank. So the situation can be solved by the inequality. W is something compared to 23 6/16. Well, remember, the box weighed 10 ounces. And if I add 10 to that, I get 16/16, which makes 1 full pound, which would make this 24, right? So that's where that number 23 6/16 is coming from. But what does W have to be compared to it? Because remember, W just represents the contents of the box, the goodies of the box. Well, wouldn't I stick with my same inequality sign, less than or equal to? There's no need to change it. Okay, so that means the contents of the package can weigh no more than 23 pounds, 6 ounces. So I think no more than is a good phrase here. You could have said less than or equal to 23 pounds, 6 ounces, but we're just using another phrase. You could have also said at most. At most would have been another good phrase. So the contents of the package can weigh no more than 23 pounds, 6 ounces, or the contents of the package can weigh at most 23 pounds and 6 ounces. Okay, now that we're done with number 3, let's look at number 4. We're back to solving and graphing. So number 4, solve x plus 7 is less than 18. First thing I'm going to do is I'm going to draw my line through my inequality symbol. And I'm trying to get that x by itself. And it's connected to a plus 7. We're adding 7 to it. So how do I undo adding 7? Well, I subtract 7. So I'm subtracting 7 on both sides. So on the side with the x, the 7's cancel out. X comes down. My inequality sign stays the same. 18 minus 7 is 11. Sorry, y'all. So x is less than 11. That is our solution. And now we just need to graph that solution. So I know on my number line, I want 11 to be kind of sort of in the middle. So I think I'm going to start at 8. So let's start with 8, 9, 10, 11, 12, 13, and 14. So I've got 11 there in the middle. Now remember, our solution had been x is less than 11, right? So what kind of circle do I want when I have a less than symbol? Keep in mind, there's no line underneath that. So I want an open circle. So at 11, I'm going to put an open circle. And because my variable is on the left-hand side, I can use this as an arrow pointing the direction I need to shade. It tells me to shade to the left. So I'm going to shade this way, and I'm going to include that arrow. Okay, so the reason I shade that way is because this means x is less than 11. Well, is 8 less than 11? Yeah, it is. Is 9 less than 11? Yeah. In fact, all of these numbers are less than 11. And we shade the arrow because even further back, 7, 6, 5, those numbers are also less than 11. Okay? So that's how we got this answer and this graph. Okay, last one, number 5. Michael wants to buy a new computer that costs $569. He has already saved $89. Write and solve an inequality to find the least amount of money, M, that Michael still needs to save before he can buy the computer. Okay, so I've kind of bolded the important information here, but let's think about it. In order to buy the computer, he needs this much money. What would happen if he saved $600? Would he have enough money to buy the computer? Yeah, he would. So I'm going to phrase this as he needs at least $569 to buy the computer. And when I think about it this way, I've got a key phrase. That key phrase is at least. Was that on our reference sheet yesterday? Yeah, it was. Greater than or equal to goes with that sign or that phrase. So I want you to think of that sign when you see that phrase. Okay? And it makes sense because, like we said before, if he saved $600, he has enough money to buy the computer. At the very least amount, he needs $569. But if he saves a little bit more than that, then good for him. He's got extra money. He can go out to lunch, right? Okay? So now we know we're going to have at least, so greater than or equal to $569. Now, other important information. He's already saved $89. So we're trying to figure out what he needs to save still. So we've got our 89 here, and we've got an unknown value. What operation connects these two pieces? Well, this is what he has, and this is what he needs. Wouldn't it make sense to add them together? So now we have our inequality. Is this an inequality that we can solve? It sure is. So I'm going to use some teacher magic and move this up a little bit. So the first thing I'm going to do is I'm going to draw a line through my inequality sign, and I'm trying to get that x by itself. So how do I undo this 89 right here? Well, keep in mind that's a positive 89. So how do I undo it? I subtract 89. So I'm subtracting 89 on both sides. Now on the side with the x, the 89 comes down. X is by itself. My inequality sign stays the same, is greater than or equal to. And 569 minus 89, if you put that into your calculator, you're going to get 480. So X is greater than or equal to 480 what? Dollars. So that right there is my solution. So all we have to do in Savas is fill in this blank right here. He needs to save at least $480. And that is the end of this review video. Have a great day.